Good morning. So we heard in the previous presentation that aesthetics is key when deploying Wi-Fi in a lot of the scenarios. So in the past, you could just put your access point up on the ceiling tile grid, whether it be one with internal antennas or external antennas. External antennas, rubber ducks or directionals would be next to them. Then the next thing that happened was like, okay, well, we don't want to see the rubber ducts. We don't want to see the external antennas. We don't want to see the access point. So then we came out with covers for the access points or ceiling tile enclosures to hide the access points in the antennas. If it was an external antenna with a patch, we came out with co-locating mounts that mounted the access point and the antenna together to hide the cables so it would look more aesthetically pleasing. So now we're starting to get more questions about, okay, I don't want to put the access point up in the ceiling. I can't put it on the wall. I have this new building design. What can you do for me? Oh, by the way, I have a raised floor now. So raised floors are not just for data centers anymore. A lot of the new building constructions are coming up with raised floors. So we've been approached by a few customers, some Fortune 100 customers as well, saying, okay, I'm getting a new building design. The architects are designing this museum-type building. I don't want to see any wires. I don't want to see any access points, but I need wireless. And we all know with architects, that's the last thing that they think about is Wi-Fi. They want to make a building beautiful, functional for the user, but, oh, by the way, we have to have Wi-Fi. So this talk is talking about a floor-based Wi-Fi system. So this Wi-Fi antenna is based on using a raised access floor. So we worked with one of the top two raised floor systems builders in the US to come up with a design to put an antenna in a raised floor so that it would fit into their floor panel system. So when a raised access floor was placed into a building, you could have Wi-Fi. And you didn't have to worry about it being, it wouldn't be seen because it's aesthetically pleasing, and you didn't have to worry about it being on the walls or on the ceiling or anything being seen. So what we have here is we have a 24 by 24 inch concrete tile with a galvanized steel bottom and a planar antenna that fits into a groove that was CNC'd into the concrete, and then sealed with epoxy, and then covered with a resin. So this shows your typical raised floor. It was something similar to this stage, right? So you have some area under the floor where the access point goes. The access point can either be on the floor or on one of the beams. We designed the fixture so that the access point can go onto the fixture so that you can have the access point elevated from the floor as well. And then on top, you have your concrete, the top of the concrete tile, and then you have a carpet or another type of floor covering. And we've looked at scenarios where we've had a minimum, can you hear me? Sorry. A minimum of 5 inches up to 24 inches of underfloor area. So this is one deployment that we did at an office building, and as you can see, the center bottom is the access point connected to the actual tile. To the left is the tile is in place, and we have the carpet up so that you can see the tile antenna. And this is an entire raised floor office space. And then to the right is with the carpet covered, so no aesthetic issues. You don't see where the antenna is, so no one knows that you have a floor-based Wi-Fi system. So what are some of the characteristics of the raised floor Wi-Fi antenna? It's a low-profile planar design. It's the first model that we have out supports 3 or 4 port access points. It's aesthetically pleasing. It's easily movable within the grid because you can pick it up and move it to a different location just in case you have some issues with Wi-Fi or there's been some changes to the modular design of the floor. And it withstands normal office activities and flooring load bearing requirements according to guidelines established by the Ceiling and Interior Systems Construction Association. So what are some of the benefits of a floor tile versus ceiling mount antennas? One, like we said, aesthetics, ease of installation, the equipment needed, lifts, pulling cables, the trays that the cables go on, cable runs in the ceiling versus under the floor. You don't have as much cable to pull, especially if you have to go up walls with the cable to get to the access point. Plenum versus PVC cable. If it's a plenum space above the ceiling, you need to use plenum cable, which is more expensive. And then AP location and protection. You can protect the AP, no one sees it, but if it's on the ceiling, there's a chance for theft. Or you have to use some of the things I said if you wanted to hide the AP, ceiling tile enclosure, things of that sort. And then for upgrades, for support and maintenance associated with reconfiguring and upgrading the APs, as well as our scalability. So if your organization grows and you need to add more access points and you didn't plan for it, you have to go back out with someone to put up the access points and run the cable. So we came up with two designs of the floor tile based on the manufacturer, and pretty much the difference of them is the thickness. One is 1.125 and the other one is 1.15 inches. And as you can see, we did static load testing and dynamic load testing because some of the questions will come up, okay, well, you're cutting away some of the concrete and you're placing an antenna in it, but what's the load bearing? How much load can this handle? What can I roll over? What can I place over top of it and it still perform, or does the concrete crack on the tile? And this is for 1,500. And as you can see, some of the load and the load parameters are the same, except that you have a higher dynamic load at 500 pounds for 10,000 passes. Some of the specs on the antenna is a dual band antenna, 3 dBi at 2.4 and 6 dBi at 5 gig. And then the vertical beam widths, and I showed two vertical beam widths in the length and the width axis. Because it's a planar antenna, it has different characteristics, length versus width as on the radiation pattern for the elevation. And this just shows some more of the specs. This is actual 3D data from a chamber to show what the antenna looks like in 3D. And just for purposes, just to show, you have 2.5 feet, because we designed the antenna for coverage of client devices at a minimum of 2.5 feet. As you know, since the antenna is on the floor, it's closer to the client device. And the average height typically of the client device is 3 feet, but if you're sitting at your desk, it's lower. So we kind of designed the antenna so to have more of a wider spread. The radiation patterns have asymmetric vertical beam width because of its rectangular planar design. So what we did was we etched arrows into the antenna PCB to show placement, so you can kind of place this in the direction that you want your coverage to be. So I know a question comes, okay, you have a floor base antenna, I'm walking on it, I may be sitting on it, so what are the SAR implications? So I'm going to get radiation into the body. So we sent it out to be tested, and it met SAR. So in a nutshell, it says down the bottom, for a person that's standing, the power out of the transmitter can be 23 dBm. And in that case, that someone doesn't know where it's at and they're sitting on it, which is your worst case, the SAR, the power level can be 15 dBm. This talks about coverage versus capacity. Omni antennas can be used for high density and much higher AP count, like under the seat in large public venues. Directional antennas, channel reuse, same floor space required, higher ceilings, 25 feet and above, available to mount the AP. But the raised floor tile antenna can be used for both coverage and capacity. The client devices are closer to the antennas. The users of these devices can also knock down some of the power as well. And then power control is key to determine whether you use it for coverage and capacity. I'm out of time, but if anyone wants to talk out, and this is just a site survey they did to show the arrows in the direction so you can show how you can turn the antenna based on how you want your coverage to look. Thanks.